4.5 is a general solution, and this is for 6 marks. Very, very important. So grade 11s, there are, I think, 6 types of general solutions. So you need to know all 6 types. But in this question paper, they ask this type when you have sine and cos, but the angles are not the same. The one is 5 theta, the other angle is theta minus 40. So this type is called the co-function type. So let's write our plan out. So this is my plan. With the co-function type, you can take your right-hand side and you change the cos to a sine, or you change the sine to a cos, depending on what is there. And how you change it is you say 90 minus the angle that they give you, and then you simplify this. Okay, so that's step number 1. Step number 2 is we don't use our calculator to find the reference angle. This simplified version over there, that whatever you get there is your reference angle. And then you choose your quadrants and you do your solutions. And you must remember, k is an element of an integer. Let's write our question down. So with the co-function type, I change my right-hand side. This is the right-hand side. And because there is a cos, I'm going to change that to sine. But remember, I still write everything down. I write this down. So this cos will now become sine. Then I say sine 90 minus the angle that was given. So this angle is 2 terms. It's theta minus 40. That's why I'm going to put it in brackets here. Theta minus 40. And then I close it. So it's always 90 minus the angle that was given. Now, I must first simplify. So I write everything else down. Sine stays sine. Now, inside this bracket, I'm going to simplify. Negative times theta is negative theta. A negative times a negative is a positive. Okay? I can still simplify because there are like terms here that you can add up. So sine, then this becomes 90 plus 40 is 130. So this is 130 minus theta. So there I simplified this. So I'm there. So I've done all my steps. Now I'm going to choose my reference angle without using the calculator. Grade 11s, let's choose. So this is now the reference angle. So I'm going to write the reference angle is 130 minus theta. Okay, so now I'm going to choose the quadrant. So I have the reference angle. Let's choose the quadrant. So do you see here, the sign in front of sine? It's a positive. So there's a positive. So I'm going to look where is sine a positive. So sine is a positive in quadrant 1 and quadrant 2. So when I start with my solution, I start with this angle. So I'm going to say 5 theta is equal to the reference angle plus k 360. Why 360? Because I'm busy with sine. So sine and cos, the period is 360. And tan, the period is 180. And with tan, the period is 180. Okay, so that's what I write in quadrant 1. In quadrant 2, I still start with this angle. So I say 5 theta, whatever is there, is equal to 180 minus the reference angle plus k 360. And now I just replace the word reference angle with the actual reference angle. This is my reference angle. So here I'm going to have the 130 minus theta plus k 360. And I'm going to finish the side quickly. So the theta will come over. So it's a plus theta. So 5 theta plus theta is equal to 130 plus k 360. 6 theta is equal to 130 plus k 360. And I'm not solving 6 theta. I'm solving theta. Divide by 6. Even the period. Everything you divide by 6. So I get theta to be 26,67 plus k 60. Okay, and that's the answer for this one. So let's go to quadrant number 2. Let's replace the word. So we're going to replace the word reference angle with the actual reference angle. So 5 theta is equal to 180 minus, now put the reference angle in brackets. So 130 minus theta plus k 360. Now we're just going to remove the brackets. So let's remove our bracket. Minus 130 plus theta. Okay? Then we take the theta over to the other side. So 5 theta minus theta is now this minus this plus k 360. So this is 4 theta is equal to 150. 4 theta is equal to 50 plus k 360. Divide everything by 4. 4 and 4. I get my theta to be 12,5 plus k 90. So I've done all my steps, and now, so I've done the solutions, and I must write k is an element of an integer. So here after I've done all my work, I write k is an element of an integer. And that's how you do the general solution there.